Okay, here's another example. Well, this does look complicated, but let's see if we can sort it out. Let's first mark up the line AD as a chord and its associated tangent, the line AE. And they are asking us to find the angle X. So really we've got to drag information from up here, the 40 and the 32, back into this triangle so that with the 180 degree rule of a triangle, we can work out what X is. The angle subtended on the chord AD is 40 degrees. And if you look at theorem number 8, the angle between a chord and a tangent is the same as the angle standing on that chord. Okay, well, the angle standing on that chord is 40 degrees. So immediately, using theorem number 8, I can say that this angle here is 40 degrees. Now, the other fact we've not used yet is the fact that this angle, which is angle CAD, is 32 degrees. Well, it is standing on chord CD. So where can we transfer 32 degrees to? Well, there's another pair of lines which are also standing on CD, which are the lines BC and BD. So this angle up here is 32 degrees. We've actually got a cyclic quad, and here are the points. And we now know the whole of the angle CBA. So the opposite angle, which is CDA, and those two angles must add up to 180 degrees. So we can say that Z plus 32 plus 40 must equal 180 degrees. So therefore, Z equals 108 degrees. Now, because the line CDE is a straight line, Z and another angle we're hugely interested in finding out what it is, let's call it Y, Z plus Y must equal 180 degrees. And Y is equal to 180 minus Z, which is equal to 180 minus 108, and that is equal to 72. So we can say that X plus the 72 plus the 40 must equal 180 degrees, and therefore X is equal to 180 minus 112, so that X is equal to 68 degrees. And we can pop that on the diagram as 68 degrees, and there we are.